an ice cream truck, has a mass of 1,800 kilograms. How much force will the engine need to accelerate it at 1.75 meters per second squared? The friction force on a paved road is 250 newtons. So this is a great example of why it's important to show the formula. Okay, so the mass is 1,800. We need an acceleration of 1.75. So given my M and my A, what can I get out of that? I can get the net force, right? So how many of you did this? F net equals MA, and then you went 1,800 times 1.75. How many people did that? Almost all of you. That's good. What's the answer? 3150. Sounds familiar. Okay. And the friction force is 250, and we always subtract friction, so we're just going to take 3150, and we're going to subtract 250. How many people did that? That's the wrong way to do it. You'll notice that I didn't write the formula. Do you always subtract friction? There's the danger with the word always, because if it's you say always, well then it means always, all of the time. And it better be all of the time. Here's what you should do. You should write F net is equal to FA. Let me get this out of the way. The net force is the applied force plus the friction force. And how much is the net force? 3150. You see how you put the number right underneath the F net? Right? And what are we solving for? How much force will the engine need to accelerate? We are solving for FA, right? And the friction force is going to be plus minus 250. And when I solve that, when I take that minus 250 and it has to go to the other side, what does it become? It becomes positive. 3150 plus 250, meaning that the applied force is going to be 3,400 newtons. You can't always just subtract friction. Lane's not smiling as much today. Now she is. You can't always just subtract friction. Think about it another way. If I need 3,150 of force to accelerate, and I have to overcome friction, don't I have to produce more? Right? Of my 3,400, 250 goes to friction, leaving me a remainder of 3,150 to do the acceleration. Does that make better sense? Do you see how writing the formula will help you algebraically arrive at the correct answer? Write the formula. Don't say, oh, it's a big waste of time. Write the formula. I'll pause. Today we're going to be looking at what I call the top-down or the top view or the bird's eye view. Okay? So this example here, now please tell me this is the same one that you guys have. Okay, so as I was saying, we're doing top-down views. Is this the example you have?
Yeah.
Yay for me. I think after 25 years I didn't know what I was doing. Two forces act on an object as shown. What is the total applied force? So remember, we are looking at it from a top-down type of view. Okay, you ready, man?
Yeah.
Okay. So, when you have forces at an angle like this, how do we add them? Remember when we go back way back to the pirate thing, how do you add the vectors? You got to put them tip to tail, right? So you got to do this, right? And so your diagram is going to be 12 and then 10 like this. And the overall applied force is going to be that one there, which we call the, remember the answer to a vector addition question? Starts with an R. Resultant, okay? So in this case here, we might call it FA because it's the total, it's the net applied force. We'll call it FA. How about I call these ones F1 and F2? Is it really important what I call them here? Not particularly. Is this all kind of making sense a little bit? Okay, I'm trying to, in the past, I haven't done as much a good job of sort of giving people this background, so I'm trying to go back in time a little bit and a little bit of review. So how am I going to solve for FA? Is it a right triangle? It is, so I can solve it by Pythagoras. So then you would say something like FA squared is equal to 10 squared plus 12 squared, right? 10 squared is 100, 12 squared is 144, so that's going to be 244, and you would have to take the square root of that. $15.6?
Yeah.
15.6 newtons. That would be our total applied force. Now this is clearly, if those are both applied forces, the 12 and the 10, and the 15.6 is our overall, is there any friction present here? Doesn't appear to be any friction, right? If there were friction, which direction would the friction be? If we call up north and left west, and right east and down south, what direction would the friction be? Say again, I heard something. Northwest, the friction would be like this?
No.
Opposite the 10? Remember, you're looking down at the Kleenex box, right? Like this. You're not looking sideways. You're looking down at it. So I've got one course this way and one course this way. So in other words, it's going this way, right? Is it not going in this direction, Trent? In the direction of the applied force? So doesn't that mean that the friction force would be opposite that? Right? It would. So that leads us into question number 2. A 100 kilogram crate being pulled in two directions with different forces, 250 newtons south, 150 newtons east. If the friction force is 50, what would the net force be? So our overall net force diagram, 250 south, 150 east. What direction is the friction? Up and the other way, right? North and west. Friction would be like this one here. Do I know the angle of the friction? Not yet. So how am I going to solve this? How do I add those two together? How do I add the 250 and the 150 together? You got to draw a resultant. Yeah, exactly. 250, 150. We'll call this one F1. We'll call this one F2, and we'll call this one FA. FA squared. Can I just do this? FA squared is equal to 250 squared plus 150 squared. Do you think, like, can you just solve all that in one step? You should be able to at this point of your math career. Right? So 250 squared plus 150 squared equals, and then take the square root of that. I get 291.5. $291.5 newtons. But the net force is the applied force. I'm going to throw it over here. The net force is equal to the applied force plus the friction force. So my applied force is 291.5. But my friction force, is it automatically negative? No. Why not, Jason?
Because of
I'm saying no. Automatically negative? It is in this case, right? It's the friction is opposite to the motion. And if the motion is in the direction of 291.5, well, then that's just going to be here, minus 50. 241.5. If you want to think of it this way, this might confuse some of you. If you want to think of it this way, this direction is the positive direction, which makes this direction the negative direction. You can assign positive and negative direction to anything you want. Because we would say, some prof might say the FA and the FF are collinear, which means they're in the same line, they're in the same plane, that we can assign one positive and one negative. But most people sort of get, oh yeah, I just subtract the friction. Do I need the angle? Alana, what do you think? Do I need the angle?
Yeah.
How come you're saying that? Because why would you be asking me if the answer was no, Mr. Mann? Right? I'm unconventional. I might ask you a question that you don't need to. But the answer in this case is yes, you do. Because why? Because the net force is a vector, and vectors have angles. So that's going to be theta is equal to inverse tan, opposite, 150, adjacent, 250. Did you know there was going to be this much math here in physics? Really? (31 degrees). And that would be, now let's just see here, that would be that angle there, so that would be south, 31 degrees, and then that would be east, wouldn't it? Right? How much do you think a question like that would be worth? 5? 1, 2, 3. Should I give a mark for the diagram? I probably would in this case. Could you do that question without the diagram?
Yeah.
It's possible, but you'd have to have a pretty good visualization skill in your head. I'd recommend a diagram. How about you guys try one on your own? How much room for you got for number 3?
Enough.
Half a page? If you're a big writer, make it a bit smaller. Maybe draw the line down the middle. Try it on the left-hand side. I'll give you the answer on the right-hand side. I'll give you about 3 or 4 minutes. Give it a whirl. Okay, so 100 kilogram crate, 2 directions, 10 newtons south, 12 newtons east. 10 newtons south, 12 east, right? So we're going to add those together. So I got 10 and 12, and I guess the 12 would be longer, wouldn't it? We're going to call that FA. So because it's a right triangle, we're going to use Pythagoras again. So FA squared is equal to 10 squared plus 12 squared. Right? So that's 100 plus 144. Didn't I do this one already?
Yeah.
244. It's exactly the same as the first one, is it not? Which was 15.6. Okay, but here's the kicker. The friction force is 100 newtons, which means it's like this. So how many people just went F net is equal to FA plus FF, and then you went 15.6 plus minus 100, and you got minus, what is that, 85, 84.4?
Yeah.
Okay, wrong. The friction force is opposite, right? But think about this. If I push on this table, this big giant table that's attached to the ground, that's a lot of friction. If I push this way, maybe Jason comes over and pushes this way, is it moving? Not going to move. How come? Because the friction is way more than we're applying. Okay? This thing is not going to move back. Like if I push like this just a little bit, it's not going to like fire me into the wall. Right? Friction's kind of like teenagers. They only do as much as they need to. If I push with 15.6, how much does friction push back on? 15.6. Because I know that the net force is 0. Okay? It's a bit of a trick. The net force here is actually going to be 0.
So give a negative net force.
You can't just subtract it. Right? You got to think. Don't just blindly always do something. You should always be thinking.
So say that was like 156.
If it was 156, then you would subtract, right? Because you've got more applied force than you do friction.
So since our friction force is more than our applied force, it's just going to be our S is going to be 0.
Exactly. Well, in fact, in reality, the friction force is actually going to be minus 15.6, right? Really, this should say if the maximum friction force is 100, right? I'm throwing that in there as a trick now, so you don't see it later, or that you recognize it later. Give me the nod of understanding. Right? You've got to check, is the friction more than the applied force? And if it is, net force is going to be 0. How about you guys try number 4 now? A 10 kilogram plate crate again being pulled in 2 directions, 2 different forces, 25 newtons west, 15 newtons south. The friction force is only 5. Now already I know, I can see the friction force is only 5. That's going to be less than the sum here, right? So it's going to be an actual subtraction one. Notice that it's asking for the acceleration. Give this one a try, and in about 5 minutes I'll give you the answer. 10 kilogram plate, crate, why do I keep saying plate? Being pulled in 2 directions, different forces. You got 25 newtons west and 15 south. Friction force is 5. What would the acceleration be? So we're going to do the same thing again. We got 25 west. We got 15 south. Do I need to draw the free body diagram now, or can you sort of visualize it, and then we can probably skip that step, right? So I got 25 and 15. That's my applied force. Use Pythagoras again. Fa squared, 25 squared, plus 15 squared. This one I'm going to have to work out. 25 squared plus 15 squared is 850. So we're going to take the square root of that. 29.2. Well, I get 29.15, so I'm going to round that to 29.2. F net is equal to MA. No, it's not. F net is equal to the applied force plus the friction force. So that's going to be our 29.2 plus a minus 5. 24.2, of course. And now I got to do acceleration. So what do I do there, Wade? Don't know? I got F net. How do I get acceleration? F equals ma, exactly. F net is equal to ma, right? So my net force is that 24.2. My mass is 10. So for acceleration, divide both sides by 10. What do you get? 2.42 meters per second squared. So again, Jason, sorry? You do. You have to find the angle. How come? Because it's an acceleration. Acceleration is a vector, and vectors have angles. So is it this one here, Jason? Yeah, that's the direction of the acceleration because that's the direction of the friction. So the acceleration is going to be in the direction of the net force, which is the same direction as the applied force. So that's going to be theta is equal to inverse tan, opposite 15, adjacent 25. I get 31 degrees. So that's going to be west, 31 south. How much would that one be worth? 1, 2, 3, 4, probably 5. You're going west and south. What do you mean the opposite?
I was thinking the other one.
Oh, the friction force.
Yeah.
Yeah. No, the acceleration is in the direction of the net force. Did I give you a problem pack? Please say yes. No. Like yesterday, did I give you a problem pack? There we go. Excellent. Okay, can I wear that here? Okay, so on yesterday's stuff, you got a set of problems that say Newton's law problem set 1. And on the back of it, it says set 2. And there's QR codes and answers, the H or E. I probably did something right. Now I will say, there's a couple questions that say force at angle. I haven't shown you force at angle questions yet. So on the first set there, number 7 and 8, and the second set, number 2. I haven't shown you those ones yet. Okay? So I would strongly suggest you do a little bit of practice over the weekend. In fact, I might even do this for some keeners. I think I will. No? This next one takes you really forward. Yes. Next one takes you really forward. Okay? You're definitely not going to do that work. Here's the next one. Takes you really forward. Here's the next one. Takes you really forward. Okay? Are you familiar with the concept of the ring thing? You know the Lord of the Rings, like one ring to rule them all? The 5 Lord of the Binders, 3 rings to rule them all. Yeah. Well, even this next one. Yeah. What are you doing? Getting that closer? Just extra one in case you need. Okay, you got the rest of this period. I know there's not a ton of time left. I apologize. Try to do a couple practice ones. Now's the time, you guys. If you do 2 or 3 questions now, that's worth like an hour of your time later because you don't have to re-figure it all out. I just showed it how you do it. Do it now.
More defensively challenged.
Well, Kurt, he's just relaxing. He's on his phone at his foot.
Doing this in the week. I'm gonna force it. I literally told you look like they're doing this something you're like, I'm not.
And after I just explain it, it's fresh in your mind. If you reinforce it now, Colby, like 10 minutes now is worth like 30 minutes later. Oh yeah, I probably forgot to do something. When you have 2 grade well, it's all about how you respond. Are you going to solve the question? Are you going to try? Or are you going to say, I'm going to do better next time? Time right now, 6-6, so that then you can go. Next inch, that's a little better.
It doesn't matter.
We're paid. Time money. Problems. There's still time. You can do it. You're writing.
I do more minimal work I can do all my
Are you fooling yourself? You're not fooling me. Either one is good. Are option 2 because you're not doing anything. Yeah, you gotta figure out the acceleration. Well, acceleration is change velocity, velocity change. That's literally the power, so that'd be
No, you said math, I'm actually gonna do it on Sunday. Maybe not on Sunday, but I'll do it Nice.
Anyone need some last minute wisdom?